Good morning, everybody. Thank you for joining the webinar. It's a very exciting webinar today because we're introducing a brand new product from Cambridge Intelligence called ReGraph. Now, ReGraph is a toolkit for building interactive graph visualization applications on the React JavaScript framework. Now, that's a little bit of a mouthful, so we're going to basically take the rest of the webinar to explain to you what that means and what ReGraph does and how it's helpful for you. To start off, I'll introduce myself and Kevin. So my name is Corey Lanham. I've been with Cambridge Intelligence for 6 years now, but been doing graph visualization for 19 years, mostly for industry and for governments around the world. And I've also written a book about graph visualization that you can check out if you want. It's called Visualizing Graph Data. About halfway through, I'll be handing off to Kevin. Kevin is our product manager, and he's the one who is responsible for setting the overall direction of our products, both Keylines and ReGraph, and also deciding which features we build and when those get released into our products. So this is what we're going to talk about today. We're going to go through why it makes sense to visualize graphs. That may be review for many of you, but we'll spend a couple of minutes on it just to explain. We'll be talking about what ReGraph is and how it's been built and what it can do for you. And then Kevin will spend a little bit of time in more detail with the ReGraph API to talk about some of the technical detail as well. And we have some time at the end for questions. So I do need to warn you, this session is being recorded. That does mean that you can ask questions now, or you can review this at any point later if you'd like. It'll be posted shortly after the webinar is finished. If you do have questions, we'll be happy to take those at the end. There's a questions panel in the GoToWebinar control panel that you can use to ask those questions, and we'll address those right at the end. So the first topic I wanted to go through is, why is graph visualization even helpful? And it's really the case that graph visualization is the most useful when you have relationships among your data elements, and those relationships convey some interesting meaning. So if you just have a list of items, for example, with a list of properties, your standard relational database table, that doesn't have any connections between those data elements, say a list of products for sale in your store and the prices of those, then graph visualization is not the most helpful way of looking at that data. But when you have connections, for example, here, we're looking at internal emails within an organization, and each person emails another person. And so each person can appear in the table multiple times. The result is that the email can be modeled as a relationship between those individuals. And then you can start to uncover some really interesting things about that pattern of relationships that you may not have uncovered by looking at it in a standard tabular form. So over here on the left, for example, we have the sender, the recipient, we have the date time that the email was sent, and the subject line, and probably other fields like the actual text of the email itself. However, if I'm not interested in looking at the text of the email or reading them, but I'm interested in the pattern, who in my company is emailing whom else, when are those emails happening, who is acting as gatekeepers of that information, or who is the most influential across the network. Those are the kinds of things where a graph model of the data and visualizing that graph can really expose a lot of interesting insight that you wouldn't get otherwise. So the key to graph visualization is when there is relationships in the data and you want to visualize and model those relationships in a way that you can uncover them and learn interesting things about them. So graphs and graph visualization are really being used across a wide variety of different use cases in both industry and in government. So these are just a few of them that we've come across in our product set. So defense and intelligence are really some of the early adopters of graph visualization. For example, looking at terrorist networks and how they might be connected to one another, or intercepting communications. In the law enforcement world, looking at criminal organizations and gangs and things like that has benefited from graph visualization. Anti-fraud is a really popular use case as well, because it involves looking at transactions, and fraud is a artificial or manufactured transaction, and being able to recognize that among the pattern of all of the normal transactions over the course of business. That could be in, say, insurance fraud or banking fraud or stolen credit cards, for example, things like that. Cybersecurity, the transmission of IP packets, infected packets, the transmission of malware across a computer network is also something that lends itself very well to graph visualization. As also just looking at the actual devices on a network itself. So where are my switches, my routers, my hosts, my servers, and things like that, and how are they all connected to one another? And I'm sure that there are many, many more applications of graph visualization that I was not able to list here, but these are some of the top ones that we see our customers using. So when you're presented with a graph problem and you want to solve that sort of problem, there's a few different avenues that you can take to create a graph visualization. Now, one is to build something completely from scratch. So taking care of building it into your application, taking care of the rendering, working with the canvas elements in HTML5, presenting that as part of a web-based application. And if you have very, very specific requirements, that may be something that you want to tackle, especially if you have a background in graphics and especially in web graphics. And then the other avenue is to use a pre-built application. So if you are trying to solve a graph problem where you're going to be loading data into an engine, taking a look at the results, publishing those results, and then throwing the engine away, then a pre-built application may make a lot of sense. The middle ground is what we produce is a toolkit. And the reason that's a middle ground is because it enables you to build a graph visualization capability into an existing web application or into a new web application, present that as part of your application, and customize all of that user experience. So it doesn't require that you have the detailed graphics knowledge from building something from scratch, but your users who are working with the graphs and graph visualization can do so in your environment and in your application with your parameters set, as opposed to having to exit to a third-party tool. So that's why we think that a toolkit can be, in many circumstances, the best approach here. Now, Keylines is a product that we have had for many years now, and is a toolkit for building web applications using JavaScript. Now, ReGraph is a toolkit for building graph visualizations using the React framework, which ultimately is JavaScript, but because it is a layer that sits on top of JavaScript, many React developers don't think in the same way as developers who are writing applications using native JavaScript. And the differences between the two are pretty significant in the way that they interact with data sources and in the way that different components can interact with one another. So we've introduced a React native toolkit that allows for developers to build things on top of React much more quickly than they would if they were writing native JavaScript. So the information over there on the right really applies to both products, both our Keylines product and our ReGraph product, that it allows you to completely customize that user experience in terms of what data you're presenting, how the users access that data, how the data is shown on the screen, how it's modeled, and things like that. And also with both products, you get full access to our support and our teams who are familiar and able to provide support on both React and on native JavaScript. So what I'm going to do now is I'm going to show you a couple of examples from our ReGraph API that show you what sorts of things you can do with ReGraph. And then Kevin, I'll hand it off after that to Kevin, who's going to go into a little bit more detail about how those are built. So the first one I'm going to start with here is one that you may have seen with Keylines. It's the same data, but built slightly differently, in that we're looking at internal emails within an organization. In this case, it happens to be the corpus of emails that was published as a result of the Enron investigation. So what we see when we model that as a graph, as I mentioned at the beginning, the individuals are nodes. The links between those individuals are the fact that those two people have emailed one another in our data set. So with ReGraph, what we've done is we've just created that underlying data set in the state of the product, and then ReGraph has taken that and modeled it as a graph automatically and shown it to you and created this interactive environment where I can scroll around and explore through it. Well, one of the important things in ReGraph is that you want to take visual properties of these nodes and links that you're showing to your users and model those to properties back in your underlying data source. So right now, what we're looking at is a graph where everybody looks the same. The nodes are these same light blue circles. The links are the same links. And we're not conveying any other interesting information from our underlying data source. But that's really the power of graph visualization, is when you can show the user the properties of those items that they expect to see without them having to drill down. So for example here, I'm going to take the width of the link and bind that to the number of communications between these individuals. So everything in ReGraph is animated, so we actually got to watch those links grow. So for example, here we have Cynthia Mann, who is emailing Sheila Tweed quite a bit, but receiving very little back in the opposite direction. And that's interesting information that you wouldn't have learned either by looking at this as a table or in its native format where everything was represented with the same links. So there we were using properties of the links to show something interesting about the underlying data, but we can also use properties of the nodes themselves. So for example, I may want to size the nodes according to their influence throughout the network, the number of connections in this case that this person has, the number of emails that they're sending out. So I can see, for example, that Tanya Jones is the largest node on the chart, and therefore she is the one who is sending out the largest amount of email, and we can see that by selecting her and selecting the links, which is the emails and the people that she's communicating with. One of the really most common scenarios with graph visualization, though, is that you end up putting too much data on the chart. And if in this example, it's not too bad, we're looking at maybe about 100 nodes, but many underlying data sources have thousands, tens of thousands, even up to the millions of nodes. And it oftentimes doesn't make sense to try to throw that all on the screen for the user to parse out at the same time. So in ReGraph, we have a large number of features which were designed to help reduce the amount of clutter and allow the user to still parse through the data and make sense of it and understand what it is that they're looking at. So as an example of that here, we can create groupings. We call these combinations, but what they are is a way of organizing subsets of nodes and representing those nodes on the chart with the node itself, but allowing you to see the detail that's behind that node and the individuals that are inside of it. So in this case, now we've gone beyond Enron here. This is actually fabricated because we don't know the management structure of Enron, but we made something up to show it. We've grouped at two different levels. So we've had the various entities within Enron, so Enron, the international subsidiary, a ventures component, and so on, and put people in the subsidiaries that they are employed by. But then within each one, there are also teams or departments that these people work in. So inside of each group, we have subgroups which represent those teams. So I can see Tanya Jones, who we looked at earlier, is part of Enron Corporate, communicating mostly within her own subsidiary, within the management team, but also to other teams within her subsidiary, but then also to a few other individuals outside of that in other groups. So while we were previously looking at 100 different unrelated nodes, by using the grouping feature, which is really powerful, we can allow end users to really look at only the areas that are of interest to them, but still see the context of everything else on the chart. What I'm going to do now is I'm going to look at a slightly different data set here. So in this example, we've taken ReGraph and we've bound it to the GraphQL engine that for Twitter. So basically what we can do is we can submit graph queries up to Twitter and get those results back. So we've built a little mini application around that just to show how it works and how you might do something similar in your application. So in this case, we can search for any hashtag that appears across Twitter. So what I'm going to do is I'm going to search for Lowell. I'm sitting here in Lowell, Massachusetts. And we see basically a graph that represents the individual tweeters who are tweeting with the hashtag Lowell. So I can see who's doing that. I've modeled that as a graph, so the tweeters themselves are nodes, the hashtags themselves are nodes, and the tweets are sitting in between the other two nodes. So I can actually read the text of the tweet here. So for example, it seems that there was a professional wrestling match here in Lowell a few days ago. So most people who are tweeting with the hashtag Lowell are referencing that wrestling match. But one of the powerful things is that I talked about earlier, reducing clutter. We're not going to bring all of Twitter into the visualization all at the same time. So what we've done here is we've created that interactive experience where the user can do what's called expand, or go off, issue a new query against the Twitter API, bring that information back into ReGraph. So for example, I think this, just judging by the picture, happens to be a professional wrestler. So if I double click on him, I can expand out and see what it is that what other hashtags he happens to be using. And mass hysteria, I believe, was the name of the event here in Massachusetts. I can then expand on that and see who else has been talking about that specific event. We've also created a pane on the left here that goes through that individual's tweets, depending on who I have selected. So I can then use other information on the same page as my ReGraph component to be able to expose additional information about that individual node, in this case, an individual tweeter, and what they've actually produced. So this kind of expand feature is a really interesting way of allowing the user to start with some sort of query. In this case, I started with the hashtag Lowell. I then used the information that came back from that, parsed it out as a graph, passed it to ReGraph, and allow the user to expand out from there to ask for additional information about some of the items that they see on the screen at first, and then continue expanding the graph from there. So they get the exact graph that they're interested in looking at, and they get the interesting information that they want to see as a result. So with that, I'm going to jump back to the slides here, and I will pass it on to Kevin, who is going to dive into the ReGraph API and talk about that in a little bit more detail.
Thanks, Corey. So as you can see, there is some great visualization potential from ReGraph, but you might be wondering exactly why it's important that this is a toolkit for React. So React is a very popular JavaScript library specifically for creating user interfaces. And as Corey hinted at a little bit, all of the updates are managed by a state object that is handed around to the various UI components in your React application. And so ReGraph is built to receive this object full of connected data through the state, and then to figure out what has changed or what it needs to do to render that data beautifully on the screen for your users. So why use ReGraph with React? Well, it is as close as you're going to get to a native React experience when you are doing graph visualization. We've had a lot of feedback from React developers that it works exactly the way that they would expect a React component to work. There is minimal product-specific API learning required. You specify things as you would for any other React component, and the API uses very natural language to determine the various properties on items. And ReGraph also takes care of all of the animations and layouts so that you can focus on creating a great experience for your customer. So with that, I am going to dive into some code because I'm sure there are some people on the line who really just want to see some code already. So when you first arrive on the ReGraph SDK site, you will have access to all sorts of things, but one of those things is over 50 different code examples. So we're going to go and check some of those out now. We'll start with this very simple welcome demo. You might notice if you're unfamiliar with React that there is, the code looks like a bit of a weird mashup between JavaScript and HTML. This is JSX, and it is a key part of ReGraph and will be very familiar to any React developers. Getting a chart into your React application is very easy. You import a chart component from ReGraph, and then you tell React that you want a chart, and you pass your object of connected data, and then ReGraph will generate that chart for you. So to see a little bit more of that state model and how that works, we'll dig into this demo a little bit. So changing your data in the world of ReGraph is really easy. You can add an item simply by adding it to the list of items that you're passing to ReGraph, and then ReGraph will handle all of the animation and the layout as you add items. And similarly, if you want to remove items from your chart, ReGraph does a really nice job of animating that as well. And so this is a very simple example of how you can simply change your data and ReGraph will handle the rest. And it's not just nodes and links that you can pass in as part of your state. You can also pass in combos, as you saw in Corey's first demonstration. Now, some of you might be familiar with combos and keylines, and we have done a lot of work to overhaul the API where combos are concerned, so that they are very easy to use in ReGraph. You define your categories that you want to combine nodes by. So in this case, we've got a group and a subgroup. And then you tell ReGraph how many levels deep you want to combine, and it handles the rest. So with those 2 lines there and a property on each node, you very quickly get to a combo that has your groups and subgroups. You can also, as part of your state, pass some layout information. So if we start with a very simple chart, we might decide that we want to view this data in a hierarchy. And then as we add more data, ReGraph is going to maintain that layout and nicely keep the hierarchy view as more data is added. There are other things that you can pass in as part of your state as well. You can pass in positions, you can adjust how long the animation takes, and there are lots of other pieces that you can look at in the reference documents for the whole details on your state. Now, the chart is not the only component that you get as part of ReGraph. You also get a time bar, and the time bar is just as easy to import as the chart. You import it right beside the chart. You specify it in a very similar way. And when you use the time bar, you can very quickly and easily filter your data down. So perhaps we want to look just at November here. Here's 1 week in November. And as we move along, we can see our data is seamlessly updated. So what else is on the ReGraph site? In addition to the 50 or so code examples, there is also some extensive documentation with live examples built in, where you can see the time bar and play with charts. There is also a full API reference, which additionally comes with TypeScript support for those of you who are developing using TypeScript. And it is also very easy to get started with ReGraph. You very simply download a copy and creating a new React app and getting your first graph visualization up and running the instructions are there. It's fewer than 10 steps to very quickly be getting going with ReGraph and graph visualization. So with that, I think we'll open things up for questions. And I will hand it back to Corey to moderate those.
Great. Well, thank you, Kevin. We do have a few questions that people sent in, but the questions panel is still open. So if any of you have questions that you'd like to raise that we can address here, feel free to do so. But of course, as we mentioned, the session's being recorded. If you look at it later or you pass it to other people who have questions, you can email either me or Kevin or the info alias that's on the screen, and we'd be happy to answer those for you. So the first question that we have is about whether ReGraph works with Neo4j, and the answer is yes. So ReGraph is designed to be independent of any specific graph data source itself, so it can connect to any graph database, including Neo4j. And the example that I showed you earlier, where we were using GraphQL to connect to a Twitter endpoint, would be very similar to how it would work with Neo4j, where you would use a cipher to connect to a cipher endpoint, and that would pass the data back to your graph. You would then update the state object and have the information that was in your Neo4j database represented in your graph. It'd be very straightforward. The second question that we have is, when would I choose to use ReGraph over keylines? And the answer to that's really simple. That keylines is for JavaScript developers or people who are using a different framework like Angular or Vue, whereas React is built exclusively for people who are using, ReGraph was built exclusively for people who are using React, and is not helpful for anybody who's not doing that because it has a dependency on that React framework. So it's a pretty straightforward question to determine whether which product you should be using. The last question we have here is which performs better, keylines or ReGraph? And the answer is that they're really both the same. So underlying both technologies is the same graphics engine that actually puts the nodes and the edges on the screen, allows for the animation and things like that. So the amount of data that you can present and the equivalent frame rates that you get when you're animating large volumes of nodes and links is pretty much identical between keylines and ReGraph. So performance wouldn't really be one reason to choose a tool over the other. Okay, we have a couple other questions that are just coming in now. So one is, are the core components between keylines and ReGraph the same? The engine is the same. So the actual graphics piece that's doing the rendering on the screen is shared between the two products. But that's about it. From the engine up, they were built separately to take advantage of the strengths and weaknesses of React as compared to some of the other frameworks or just native vanilla JavaScript. And the next question is, do you have graph algorithms in the tool? And the answer is yes. So just like with keylines, it can run graph algorithms, determine, say, closeness, betweenness. Some of those things were things that I showed in the Enron example, for example. So looking at the shortest path between two nodes, looking at the number of links originating from nodes, finding out who the neighbors are of specific items, and things like that. Just like within keylines, those are in ReGraph as well. The next one is, which of these two do you guys improve first? And the answer is that they're independent streams, although they're relying on the same engine. So an improvement to the engine would automatically affect both products. Other than that, they're different development streams. We may add features to one or the other depending on where they're the most relevant. And I think that's all the questions we've got. So thank you very much for joining the webinar. If any other questions arise afterwards, feel free to reach out to us directly, and we'll be happy to address those. Have a great day.